Sorry, the demo didn't work. All right, so our second speaker is coming from Turbine Labs. Mark is the CEO of the Turbine Labs. He's going to introduce Envoy. So this is totally changing gears on the microservice side.
Yes. So this is the first time I've spoken at anything related to big data or big analytics. So I'm interested to see how relevant this is. How many people are more on data infrastructure versus like data science? Data infra? Hands? Cool. Containers? 2, 3. Okay. Keep going. Cloud? Who's on a cloud? Who's in bare metal? Bare metal, raise your hands. Nobody. One? Awesome. Okay, so how many people have heard of Envoy as a proxy? One? Okay. How many people have heard of Nginx? Okay, so people know Nginx, people know proxies. I'm going to go through mostly why you would consider putting a proxy in most of your network calls, and specifically why Envoy is a good choice. Feel free to interrupt at any point. I don't know a ton about data infrastructure, so if something's totally off base, I'm happy to go through it, and happy to hear about what you all do at the infrastructure level. So why consider leveling up the proxy infrastructure at all? In the olden days, when we all had physical data centers, we had dedicated teams doing network stuff, and they maintained these nice fancy boxes. They were pretty reliable and had a ton of controls and very expensive software products around them just to maintain a network. When people moved into the cloud, all those things got taken away because the cloud provider doesn't actually give you access to any of that stuff. So you're left running on top of a virtual machine that runs a virtual network, on top of maybe some physical network that Amazon has that you can't really poke into. And so, 2001 through 10, a network team was pretty common in most organizations. And it's been interesting to see that in most startups now there's not a dedicated network team because in cloud world, there's really not as much for them to do. And so people kind of gave up on a lot of the things that you could do at layer 3 and 4 that made systems really fast and reliable and easy to use. What people have done recently is move a lot of that stuff back up to layer 7. And so that's where proxies have been kind of making a comeback. And that a lot of the things you used to be able to do at layer 3 and 4, you can't. But if you put a proxy in place, you can do it at layer 7, which is kind of fun. Specifically for data folk, I think proxies are an interesting thing because big is kind of intensely tied in with distributing things across multiple machines that talk across a network. Most of the big data packages have their own distinct protocols and clustering mechanisms and ways to communicate across large numbers of nodes. But those networks run into problems. There tend to be, at least at places I've worked, not a ton of visibility into how those nodes are communicating across the cluster. So when things get slow, it becomes a really hard problem to diagnose in most environments. And this is because, well, it's hard because it's hard, distributed systems are hard, but it's also hard to know exactly why or where that slowdown is happening because there's not many observability tools built into those clustering protocols. Adding proxies into that gives you an interesting point to do a few things. Wait, that's too fast. The back button does work. And that's really the ability to get a view into how traffic is flowing across the network. So if you've got an HDFS cluster with hundreds of nodes, and there's data flowing back and forth across those things, knowing where there's a hot link between two systems and you need to go spread data around, or if there's a broken link in between two systems, Amazon's connectivity between different AZs and regions sometimes gets slow. It's interesting to be able to pinpoint that. The proxy also gives you a way to configure resilience strategies. So in something like HDFS, they generally have tuning parameters that are local to that. Most data pipelines, I'm guessing, don't sit within a single cluster end to end, and you have to talk to external systems. And so things like configuring retries and timeouts and circuit breakers and other resilience policies are things that are more easily handled at the proxy itself rather than having to go into a specific program and configure it in the network library and roll out or deploy to get a new system in place. Cool. This is kind of a, when considering a proxy, what should you look at in general? This applies to pretty much any open source tech one would use, or even commercial tech. And while Envoy is a new proxy proxy that has a lot of great features. It's in production at Lyft. It deals really, really well with modern Kubernetes, highly dynamic environments. There's a certain baseline for new tech that needs to be met that's in the non-functional requirements realm. So we look at things and say, is this supported? And supported isn't just, is there a commercial entity that you can pay and yell at when things go wrong, but is there a community around it? How diverse is that community? In the sense, are there multiple companies supporting the thing? Or is this an open core deal where there's a small commercial entity that supports it and really is holding back stuff to get you to pay for it? Is this something that's going to have, particularly in the case of proxies, an appreciable performance impact? A lot of the stuff that we were just talking about with the Spark presentation is eking performance out of bare metal. And so adding new tech that's going to sit in the middle of a network hop needs to be pretty low overhead to not make the benefits outweigh the costs. The other way around, costs outweigh the benefits. And then predictability becomes a big thing here. So when you're messing around with network stuff, one of the things that was particularly problematic in past lives was building something in a garbage collected language where there would be surprises along the way. How many people are using Spark? I forget, there were hands. How many have spent an appreciable amount of time tuning garbage collection in Spark? Nobody? You're lucky. Okay. A good chunk of my job was tuning garbage collection for online systems on the JVM. It was super fun. Envoy is an interesting one on the scorecard. It's one of the reasons that we're super excited about it. It has maintainers from Lyft, Google, Apple, and our company. Each proxy uses tens of megabytes of RAM, so as opposed to standing up a pretty large JVM process, you can attach Envoy as sort of a co-process to any job running, and it's not going to use too many resources and give you all kinds of benefits with managing and observing the network. Speed, it's not quite at the benchmark of an Nginx or HA proxy, which have been around for a lot longer. Envoy gives you a lot of benefits in flexibility, and it's fast enough for most jobs. If you're not in danger of saturating a network card, which I'm guessing some Spark jobs are, you're usually fine. It's also a pure C++ process, so there's no garbage collection involved. It's pretty much statically allocated. There's not a lot of surprises around hiccups in performance because it needs to clean up after itself. So, observability. If you think about a proxy sitting there as a conduit for network traffic from a process out to the global network, you're in a very interesting position to capture statistics about how many requests were made, how long did they take, how many failed, and all kinds of other things that give you a very good view into what traffic is flowing from application to application, or node to node, or container to container, and really not give you wisdom per se, but intelligence about what's going on. It's data that you can use to observe, gives you a good head start on incident response, and just more information about getting to a root cause. It also supports tracing out of the box, which is interesting for data pipelines. So it would, how many people use tracing in their environments, distributed tracing? Okay, all right. So particularly as call chains get more complex, it's important to have a path of a call came in, a customer complained that something was slow. I want to see which services that thing touched and how long each call took, so I can get to some indication of which system is at fault, so I can go fix it. And Envoy will generate and propagate all the trace and span information you need to give you a complete end-to-end picture of why certain calls took a long time. Good. The next thing is, once you've observed this system behavior, when we work with people, we go through this high-level exercise of what do you want your customer experience to be, and some people haven't defined that, which is a little sad. But if you think of a site like Lyft, there are certain core user metrics that are very important. Like I summon a car, that should take 99.9% of the time. That operation should complete in less than 500 milliseconds, because it's very important for users to be able to know that I need a ride, and I'd like a car to show up. If those things start taking 10, 20, 30 seconds, users go away and use Uber instead. So those things are important to get right. When you build up that chain with tracing, you can start assigning budgets to each bit, each piece of software that makes up that call. And so you give those things effectively an SLA. So this particular call should take this long. with this histogram, I need to be able to handle 100,000 of them per second, and I need them to succeed 99.9% of the time. With that in hand, you can configure policies to make your system more resilient. So every system has a timeout, whether that's implicit or explicit. In most cases, making implicit things explicit is a good thing in software design. So saying, look, I'm going to try and make this call. If it takes longer than 500 milliseconds, stop, is a thing you can apply at the proxy layer rather than having to configure that in every bit of software that goes out. You can combine that with retries to say, look, my budget is 500 milliseconds. Why don't I time out at 250 milliseconds and give myself another try, just in case I hit a system that's undergoing some exceptional event? I can abandon that request and try another one and still be within my budget of 500 milliseconds. It's interesting because there's a lot of systems that you can get like another 9 of reliability out of just by applying a retry policy. And so this is something that we see rolled out pretty effectively. The last thing you can supply here are circuit breakers, which is really the, I will be able to handle this many requests per second. Anything above that is out of SLA, so I will just stop processing requests at that point and return, generally in HTTP land, a 500 code that says, look, there's too much load here, I'm not going to handle your request, please stop trying. And this is interesting combined with retries. The problem with retries is if you start overloading a system, retries actually make the problem worse because things time out and they retry and they start increasing load on a system that's having problems. Circuit breakers return a different 500 code, and I always get them mixed up. But the circuit breaker returns a code that the client interprets as, this is the problem because too many people are trying, I won't bother retrying, I'll propagate the error back to my caller. So this allows you to configure a system that is pretty resilient even in the presence of a very deep RPC chain to handle user action. One of the areas where Envoy really shines is in these ephemeral environments. So once again, in the olden days, you had machines that ran a job, and those machines would have uptimes measured in months, sometimes years. They didn't go away. You configured them in DNS, and you just kind of forgot about it, and service discovery wasn't a thing. As people move to the cloud, Amazon doesn't really let you have uptimes in the year range because they murder machines. And so you had to have more sophisticated service discovery. DNS got more complicated, and people have been pretty okay with that for the last few years. Moving to Kubernetes or something like it makes all this go out the window because Kubernetes will reschedule pods very frequently. And so having a list of IP addresses in a file is no longer good enough. So Envoy does some really interesting things with this, allowing you to provide a service that hands out endpoints to Envoy. And so in the case of Kubernetes, you have a central job that just gets a list of pods and their IPs, distributes that to a bunch of Envoy processes. So when a pod gets unscheduled, that IP address is removed from all the envoys. When a new pod comes into being, that IP address is handed out to all of them. There's no more managing files. There's no more dealing with DNS caching. Things just work. Envoy also doesn't actually believe that service. It uses its ground truth of I'm able to communicate with a thing, even though you told me it wasn't there, to deal with instances where something like kind of dies or is removed from the table, but will still handle requests. So it has this nice table of, I health checked it and it was okay, and it's been discovered, so I'll route to it. The health check failed, but it's still in my route table, I won't route to it. So you can see this kind of Boolean matrix. So its endpoint service is kind of an advice thing, and it treats service discovery as not an atomic, strongly consistent operation, but something that's going to be ephemeral and change over time. And it should deal with discrepancies between the thing handing out endpoints and the actual endpoints that are up in a cluster. So particularly for data land, one of the most exciting things about Envoy is it's a much more extensible proxy than other ones that have been in existence. If you think about Nginx, it really did HTTP and TCP, and that was it. If you wanted to do something with Kafka, it was like, okay, we'll treat that as TCP. You get no additional information about the protocol there. You can't collect like per operation stats. It's just going to be Envoy at its core is a TCP proxy with filters. HTTP is a filter, gRPC is a filter, Mongo is a filter, Redis is a filter. Lyft is sponsoring this year, I believe, a Kafka filter. And so you can get a lot of the same things you got from Nginx's HTTP support with Envoy across different protocols. So if you think about Redis, you can get a log of operations on Redis per node. The same thing with Dynamo. When they have Kafka, you will likely get things like stats per topic. So this node is accessing these topics. It's accessing them across these specific nodes. We give you much deeper visibility into what's going on across that infrastructure.
Does it?
Oh, go ahead.
Does the proxy handle any application level protocols,
Like?
higher level, such as instant messaging across, the ones that are popular right now?
So it doesn't do instant messaging per se. It will do gRPC. I think most of the instant messaging protocols are probably still on, what do they use now? Not XMPP, maybe something still XMPP.
It varies. There's a small amount of XMPP, but mostly proprietary.
So writing a filter is not terribly hard. And especially with XMPP, I believe that's usually on top of HTTP. So if you think about the HTTP filter, you can chain another filter on top of the HTTP one to say, the payloads for this will be XMPP, and I can write logic to handle that. It also allows you to write filters as Lua scripts. So for that sort of thing, like parsing XML is pretty straightforward in Lua. So if there are specific things you want to pull out as stats or headers, you can have an HTTP filter chain, a Lua filter chain that you load dynamically, and you can generate additional stats from that. It's pretty nice. And then I believe this is the last bit of real Envoy benefit. The routing capabilities it has are a new level of sophistication on top of what people are generally used to. So Nginx and HA-proxy both treated nodes as just a host or a port, an IP import, and maybe a wait. Envoy allows you to attach arbitrary metadata to these nodes, so you can do things like this IP import is running the software built from this Git branch, running in a production environment, whereas this node is running in a dev environment. You shouldn't send any production customer traffic to it, but if a dev wants to test a thing, like, it's fine. And then it can use information from headers to say, here's a developer requesting that their traffic be sent to their dev branch that's deployed. I'll route traffic to the dev instance. This one's a production customer, it should go to a production instance. This allows you to do load balancing across different clouds. You can roll out new software versions this way. So what our company does is deploy 2 new things, or deploy a new version of your service, route 1% of traffic to the new thing, look at the stats across the different versions. If anything goes wrong, just don't route to the new thing. We've considered how that applies to more pipeline-based workloads. Envoy also has the ability to copy traffic to an endpoint. And so for like log ingest, there's the opportunity to say, I'd like to take 1% of my incoming log messages and tap them to a different topic and keep those aside for doing testing without disrupting production use. So pretty interesting use cases there. Solutions creating problems. One of the things that Envoy really has as a unique feature is what they call the control plane. And so we talked a little bit about being able to hand out endpoints dynamically. Almost every aspect of Envoy can be configured from a central service. So instead of passing out a file, you can give it a URL to a gRPC service to say, go here for your config. And it will open a watch and pull config dynamically from that thing. So if you decided you'd like to tune resilience policies, like something's gone wrong and you'd like to change the timeout policy, with the central config service, you can edit it there and it will broadcast to all the running envoys without having to push a new config. If you'd like to change routing, you can do that. And so if you're doing software releases the way we do, we don't actually update any running envoys. We just update the routing configs to say there's a new version of software, we'd like you to route 1% of traffic to it. So it really neatly separates the deploy of a thing from the release operation of a thing. Getting a simple one of those things built and deployed is pretty straightforward. Building and management infrastructure on top of that is kind of the last stage of Envoy rollout right now. There's not a ton of people there. Lyft is probably the furthest along because they wrote the proxy. There are other service mesh things that provide a higher level of abstraction now, like Istio. But what you're looking for at this stage is really a way to pull certain services out of code into the proxy that we call meta services. So handling authentication and authorization and auto logs of who's accessing what, the resilience policies we talked about. A lot of those things can be pulled out of actual application code and put into the proxy. And that gives you not only a centralized point of control for those things, but it also means that those policies are now runtime agnostic. So if you had most of your stuff written on the JVM and it was running well and somebody wants to deploy a Python app, you don't have to put all that stuff into a Python library for the Python people to use. You tell the Python people to route traffic through the proxy and the policies get applied there. There's a lot of work to be done to make these workflows accessible to generalist developers. And so accessing Envoy configs directly typically isn't done by a large swath of the engineering team. Those things are complicated and specialized. But this central control plane allows you to build a workflow where generalist dev can say, I'd like to release 1% of my software with a new version, and you can write some veneer, some porcelain that lets them do that easily, that communicates with the thing. And then the last stage on the right is where a lot of people are working towards right now, which is this closed loop system to say, I'd like to observe the state of my system, collecting all the telemetry from my proxy. I'd like to see whether that matches my target SLA for my system, within my latency budget and success rate budget. And if I'm not within it, I'd like to make changes to make sure I get back within SLA. And the people we're working with right now are pretty excited about being able to take that sort of style of managing services and push that out to individual development teams. So the internal ops team doesn't have to manage availability for individual services. Pretty neat for them. Any questions on that? Yeah. Oh.
So with Envoy, so with the circuit breakers, other circuit breakers are actually programmable. So what I'm trying to ask is, so you said that there is no way of retrying, but like if I really want to override that, and if I actually want to implement retries,
Yep.
could I do that?
You can. There's several different ways that the circuit breaker logic gets propagated back to Envoy. I believe there are ways to override that. The most common one is there's priority routes. So you can get 2 levels of routing priority in Envoy. So if you have something that's super important, like the customer wants to buy a thing versus the customer wants to look at an image of a thing, you can make buy a thing a high priority one with a different circuit breaker, and look at the thing a lower priority operation with a lower level circuit breaker, so you can ensure the higher operations get in.
So you said the Kafka layer was coming?
That Lyft is supposedly sponsoring that one. I haven't seen a ton of progress on pull requests, but there's a pretty wide variety of protocols out there right now. So between Redis and Mongo and gRPC and HTTP, there's a pretty rich set implemented. So I think the Kafka one's not going to be a ton of work.
Do you see it doing anything more than monitoring? Because I'm trying to think of how you could have a smart proxy doing like canary testing and an asynchronous consumer model, and it's a fascinating idea, but I'm not.
It's unclear. I know Lyft internally has a ton of usage around Kafka, and I think they have concrete use cases they want to implement, but I'm not familiar with the total breadth of them. I think tracing is one that they're very interested in. So being able to take, one of the things we did at Twitter that I think is carried over to Lyft is there are certain operations that you know are going to be expensive on a front-end call. And so the general strategy is like, take the thing, stick it on a queue, get off the wire, return a response. But you still want a trace to say, like, I put it on the queue, when was that operation I deferred finally completed? In Twitter's case, it was generally fan out. Like, I post a tweet and I say, cool, I have your tweet, I'm off the wire, it's in a queue. And nobody else sees it until there's like a ton of processing done down the line. So you still want a trace generated to say, you know, what's our average fan out time for tweets?
Yeah, we're highly asynchronous.
having that all as proxy layer would be nice.
Other questions? All right, thank you very much, Mark.
Thank you.
Apologize for the delay today, so sorry, so the demo didn't work, but Shanri gonna give you the video so I can post it on the meetup page. Thank you all for coming, so we'll see you next time.
All right. Thank you. And here's the